These are your Integrated Math 2 Section 3.3.2 notes. This is part 2 of 2. And our learning target is I can investigate a quadratic function written in factored form. So factored form is f of x equals a times x minus r sub 1, which is root 1, times x minus r sub 2, which is root 2, or you can think of it as the zeros as well. So all the other vocab is the same as part 1. Just now we're dealing with factored form versus standard form in the last video. All right, so let's investigate y equals negative 2 times x minus 3 times x plus 1. We have the a value is right here. It's the negative 2. So there's your a value. Our first root, it's x minus r sub 1. So that means the 3 is actually positive. So r sub 1 is 3. And then it's x plus 1, but we know the formula is x minus root 2. So we know this is x minus negative 1, which becomes x plus 1. So this is actually negative 1. All right, so from this, I can go ahead and graph our zeros are our roots. Our zeros are going to be x equals 3 and x equals negative 1. So anytime I ask you for zeros or roots, you can write it this way. X-intercepts, I prefer that you write it the ordered pair. So it's going to be 3 comma 0 for the x-intercept and negative 1 comma 0. So let's plot those. Negative 1, 0 is right here, and 3, 0 is right there. All right. So now, to find the axis of symmetry, a couple ways we can do it. With the graph, we can just kind of work our way to the middle, right? You're at negative 1 and 3, you work 1 in. Now you're at 0 and 2, you work 1 in, you meet in the middle of x equals 1. Okay? But sometimes they're not as close, so you want another way to be able to do this. So the other way you think of this is you're trying to find the average of the zeros or the roots. So if you need a formula to find the axis of symmetry, I'm going to say LOS for line of symmetry. It's going to be root 1 plus root 2. And there's two numbers we're adding, and so we divide by 2. Okay? I don't really care if you memorize this formula. This would be x equals this. Just remember, you just average the zeros. And that gives you the line of symmetry. So in this case, we're going to get x equals root 1, which we said was 3, plus negative 1, and divided by 2. So we get x equals 2 over 2, which is 1. So my line of symmetry here is x equals 1. I'm just going to do a dashed line to represent the line of symmetry. And now, to find the vertex, we know the vertex is on the line of symmetry. So what we want to do is substitute x equals 1 back into the equation and find the y value. All right, so that shouldn't be too bad. We're going to substitute 1 for x there and 1 for x there. So we're going to get y equals negative 2 times 1 minus 3 times 1 plus 1. All right, that becomes y equals negative 2 times negative 2. Right, 1 minus 3 is negative 2 times 2. 1 plus 1 is 2. All right, so negative 2 times negative 2 is positive 4. 4 times 2 is 8. So we get y equals 8 when x was 1. All right, so that's my vertex. My vertex is going to be the point 1, comma 8. So we can graph that point 1, 8. There it is. All right. So now, just like we did before, we want to fill in the table, make a nice pretty graph. So the next value I probably would substitute in would probably be x is 0. All right, that should be easy math. 0 and 0, I'm going to basically go negative 2 times negative 3, positive 6. 6 times 1 is 6. All right, so when x is 0, y is 6. Boom. And then can I mirror the other side? I'm 1 away from the line of symmetry, so I go 1 away to this side. All right, it gives me a good start to the parabola, but I want to use this part of the graph as well. So I always want your parabola to use the entire graph that you're given. So we should probably go one more out. So what are my options to substitute in for x? I could go with negative 2 here, or I can go with 4. I think I'm going to stay away from the negative numbers, but keep my math simple. I'm going to use x equals 4. All right, so we're going to substitute 4 in for x. So 4 minus 3 is 1. Negative 2 times 1 is negative 2. Okay, and then 4 plus 1 is 5. So negative 2 times 5 is negative 10. All right, so when x is 4, y is way down here at negative 10. All right, so now I know that's 3 away from my line of symmetry, so I'm going to go 3 away to the other side. 1, 2, 3. So think about it, going up over the line of symmetry to the other side, 3 away. Now I use my whole graph. I take my writing instrument and I try to draw a smooth curve the best I can. It's kind of hard on the smartboard, but all right. Hopefully yours is prettier than mine. Okay, that gives me the ballpark of our parabola. Okay, what's our domain for this parabola? The domain is x equals all real numbers. Okay, because the x's could be any value of x you can plug in here and get a value for y. All right, and then the range, it's not y equals all real numbers because y can't be 9, 10, 11, and so on. The highest value y is 8. So y is going to be less than or equal to 8. Less than or equal to 8. Our y-intercept, we actually found it when we substituted 0 for x, and we had 0, 6. So that's our y-intercept. Interval of increase. So that is what values of x, as you go left to right, from smaller numbers to bigger numbers, what values of x are the y's going up? So we start way back at negative infinity, and as we approach x equals 1, right, the y values are increasing. Okay, so again, as I go along the number line of x, as I'm getting bigger and bigger x values, my y's are going up until I get to x equals 1. At that point, it bounces. Okay? And so then from there, the y's are decreasing for the other half of the parabola. So how do we write this? Interval of increase, I want the lower limit and the upper limit, which are going to be negative infinity and 1. So x is going to be less than 1 and greater than negative infinity. Again, I want you to have the limit because later on we'll be writing this using interval notation. It's going to make it an easy conversion to do that once you learn how to do it this way with your inequality. All right, interval of decrease, that's the other side. Again, as x are still getting bigger now, but the y's are going down. So as you get bigger than 1, 2, 3, 4, 5, 100, 1,000,000, 10 million, infinity, right? What's going on with y? It's going down until you get to infinity, okay? Which you virtually don't touch. All right, so we have x is less than infinity, and it's greater than 1. That's your interval of decrease, okay? If I wanted to get standard form, what would you do? You would multiply this out. So you multiply these binomials, then you multiply that by -2. We have a lesson coming up. The next topic, we'll learn how to do that. I showed you a sneak preview in class, but right now you don't need to know that. Just for the future, we can go from factored form to standard form by simply multiplying this out. All right, that's it for part 2 of your notes. Thanks for taking your notes.